Okay, in today's lesson, what we're going to do is we're going to be working on multiplication comparisons in real world problems. So we're going to be looking at like real things that happen and then how we can use this idea of multiplication comparison with those. So here's our first problem. It says the projection screen in the school auditorium is 5 times as long and 5 times as wide as the screen in the library. The screen in the library is 4 feet long with a perimeter of 14 feet. What is the perimeter of the screen in the auditorium? Okay, so first, it looks like that the only information that we can probably use is this one about the screen in the library right there first. So let's draw a picture to show that screen. Okay, so this right here is representing the library, so let's type library. And it says that the library has 4 feet long. Okay, so let's write 4 feet over here. Well, it also says that it has a perimeter of 14 feet. So if I know that this side is 4 feet, then I know that this side is 4 feet. So the perimeter altogether is 14. So I know this side is 4 and this side is 4, so that's 8. And I'm trying to get the 14. I can put a 3 here. And a 3 on the other side. And I think that's 14. 3 plus 4 is 7, plus 3 is 10, and 4 is 14. Good, so we have a perimeter of 14, and then the top side is 4 feet. So let's look at the rest of the problem. It says the projection screen in the school auditorium is 5 times as long and 5 times as wide. So let's look at this and let's try to make this maybe a little smaller. Let's group it together. Make it a little smaller so we have some more room. Alright, so we figured out this is really the first step right here, is to figure out the library screen. Now it says that it's 5 times bigger. Wow, that's pretty big. So let's draw that one. This one is the one in the auditorium. So let's write auditorium so we know the difference. Okay, look, it's even bigger right there too. That's pretty cool. So this is 5 times longer and 5 times wider. So if it's 3 here on this side, then 5 times more would be how much on the other side? So we're trying to think of 3 times 5. Well, I know that 3 times 5 is 15. Okay, see that 15 shows 5 times more. Okay, because it was 3, and 5 times more than that is 15. Okay, so the top is 5 times more too. So we know that we have 4 here. What do you think the top would be if we had 5 times more than 4? 5 times more than 4. 5 times 4 is 20. And there's our 20 feet. Well, that's not the rest of the problem. The rest of the problem says, what is the perimeter? So we have to figure out that this is 15. So we know that the other side is 15. And we know that the top here is 20. So we know that the bottom here is 20. So remember what we know about perimeter. Perimeter is going all the way around the object. So we know that this one was 14. So let's go all the way around this one. Let me add these because I think this is going to be easier. 15 plus 15 is 30. 30 plus 20 is 50. And 50 plus 20 is 70. So distance around the screen in the auditorium is 70 feet. Okay, and that is our answer for that one. 70 feet all the way around. And it's 5 times bigger than the one in the library. That was a pretty awesome problem. A lot of work there to do that one. Okay, well, let's check on the next one. We have 5 to do. So let's check out the next problem and see how we do with this one. Problem number 2 says, the width of David's tent is 5 feet. The length is twice the width. Okay. David's rectangular air mattress measures 3 feet by 6 feet. If David puts the air mattress in the tent, how many square feet of floor space will be available for the rest of his things? Okay, this is not too bad. Let's think about the tent first. So here is his tent. That's where he's going to be. The tent is 5 feet wide, so let's do a 5 feet. And it says the length is twice this. So if we have twice as much as 5, well, 2 times 5 is 10. So this one is 10 feet. There it is. This is his tent that we just made. It's 5 feet wide, and twice the width is the length. Good. Now it says David's rectangular air mattress measures 3 feet by 6 feet. So this is the part that we need to figure out right here. Okay, so let's draw his mattress. Okay, so here's 3 feet. Let me write this down. So 3 feet on his mattress. Let me put it up here. 3 feet. And the other side is 6 feet. Okay, so here is his mattress. Now he's going to put it into his tent. So we're going to put it into the tent. And they want to know, well, how much room is left? So let's pretend that we put it like way up here in the corner. Okay? So what they want to know is how much room will be available for the rest of his things. So let's think. If we know that 5 times 10 is 50, and 3 times 6 is 18, how do I find out what's remaining? Hey, you know, this reminds me of that part hole that we did. Here's the whole tent. Here's part of the tent that takes up the mattress. We're trying to figure out the other part. Do you all remember what happens when we have to figure out the other part? Well, if you remember, we have to subtract. That's right. So here was the tent, the whole tent. Here was the mattress. And what's left is when we subtract. So good job if you remembered how to do that. 0 minus 8, we know we can't do, so we have to move over to the tens place. Tens place, we cross out the 5 to make a 4. We take one of those tens and move it to the ones. And there we go. 10 minus 8 is 2. And 4 minus 1 equals 3. So there's 32 squares left over. Awesome. Good. You guys did a really nice job with that one. That was a pretty hard one, I think. But not too bad. Okay, let's move on to number 3. Okay. This one's kind of a tricky one, but we'll make some good sense of it. It says Jackson's bedroom has an area of 90 square feet. The area of his closet is 9 times that. The area of his bedroom, bedroom right there, is 9 times that of his closet. All right. So if we have his bedroom and 9 times, so wow, you know, if we had 9 times that, that's a pretty small closet, right? So let me think. If I knew that was 90, and 9 times, well, how much is this little piece right here then? I think this is what they're talking about, that it's 9 times that much. Oh, they don't want to do that. 9 times as much. Well, you know, if you're thinking that Each one of these little things are 10, 10, 20, 30, 40, 50, 60, 70, 80, 90, and it's 9 times that much, then this one has to be 10, right? So one of these little pieces right here is 10. So, like, what should I do on that one? So this piece is 10, and that's about the size of his closet. Okay, so let's draw that out a little bit more so we can see what that looks like as far as his closet. Okay, so one of these little pieces is like this, 1/9, right? And it says if the closet is 2 feet wide, so this is 2 feet wide, how much is the length? Well, I know this whole thing is 10, because remember I did that over here, 10, 20, 30. If the whole thing is 10, this part is 2, then what should be up here? What do you think? Well, 2 times something equals 10. Let me think. Well, if you think 5, you're absolutely right. Because 2 times 5 equals 10. Awesome. That was a little tricky one. Not too bad, though. Pretty easy, I think. I don't think it was too difficult. But you just have to remember this part, because it's almost like dividing this up into 9 pieces. So a little tricky, so make sure you're really listening to how that works out. Okay? All right, number 4 I thought was probably the harder one. So let's take a little bit of time on this one. This one says, Katie cut out a piece of wrapping paper that was 2 times as long and 3 times as wide as the box that she was wrapping. Okay? We won't worry about this part until a couple minutes from now. Let's worry about this part. The box was 5 inches long and 4 inches wide. So let's draw our box. Okay? And then we'll worry about the rest. Okay, so we have 5 inches long, okay, so this is 5 inches long and 4 inches wide. Okay, now it says Katie cut out a piece of wrapping paper that was 2 times as long. All right, so let's take all this. Let's group it together real quick, and let's see if we can do a little bit of math to get this one done. All right, so let's figure out the wrapping paper. Let's draw the wrapping paper. It's a lot of wrapping paper. And you know what? Let's color it real quick. I think, you know what I like? My wife likes purple. So let's do purple wrapping paper. There we go. All right, so we got this wrapping paper here. All right, let's figure out the math part. It says Katie cut out a piece of wrapping paper that was 2 times as long. Well, remember this one was 5 inches, so if it's 2 times that, 2 times 5 equals 10. Nice. Okay, then we got the second part. And 3 times as wide. Remember, this was 4 inches wide, so 3 times this side gives us 12 inches. You know, it was kind of a weird picture because this one is supposed to be longer, but you get the idea of how we're supposed to work it. You know what, let me just make it smaller so it looks like it's the right way. Okay. So we got our picture. Now the question asks this. What is the perimeter of the wrapping paper that Katie cut? Remember, perimeter, we have to go around this object. So if we know that this side is 12, then we know this side is 12. If we know that the top is 10, we know the bottom has to be, you guessed it, 10 too. Remember what we got to do for perimeter? It's length plus width plus width. So we're going to add all the way around. So let's do 10 plus 10 plus 12 plus 12. And you'll get your answer. So look at it for just a second. The answer is 44 inches. So hopefully you got that on your paper. That's not too bad. That was a pretty easy one, I think, for you. All you have to do is just multiply 5 times 2 to get 10 and 4 times 3 to get 12. Do the perimeter all the way around, and the winning number is 44. So that shouldn't have been too bad. I like this creative pen. It's kind of cool. So here is your answer. Ta-da! Good job, Mr. Chandler. Okay, let's move on to number 5. This one says, oh, Alexis is in this problem. Alexis has a piece of red paper that is 4 centimeters wide. Its length is twice its width. She glues a piece of blue paper on top of the red piece measuring 3 centimeters by 7 centimeters. How many square centimeters of red paper will be visible on top? All right, so let's figure out what Alexis did here. She's got this piece of red paper. So let's draw some paper so we can see what it looks like. And then she has this blue paper, so we'll draw that too. Okay, so let's color it in so we know the difference. Remember, this one was red, and this one was blue. Okay, so let's talk about what these are. Alexis has a piece of red paper. Here's the red one. 4 centimeters wide. So we know this is 4. Okay. Its length right here is twice its width. So if this is 4, twice that would be 8. Okay, if there's 8. So then she takes this blue paper and she puts it on top. Well, let's see how big this red paper or this blue paper is. This one says 3 centimeters by 7. So let's do 3. By 7. Alright, so here we go. Here is the blue paper. So if this one right here, okay, well, let's look at the problem one more time. How many square centimeters of red paper will be visible on top? So if we put this blue one on top, what it's saying is how many square centimeters of red paper will be visible on top. So here's the thing. If we want to know what the difference is here, what can we do? How do we find out the difference between things? Well, if you're thinking of subtraction, well, subtraction, you're right. Good. So let's take 8 times 4, which is 32. So 32 squares. Okay, so that's these two multiplied together. And let's take this one, 3 times 7, which was on your quiz. We know that that one is 21. Let me think. Remember what you said when we are trying to find the difference between this one and this one. Difference is we are going to subtract. So we have 32 centimeters. Take away 21 centimeters. And what do you think we'd get for that answer? Let's subtract real quick. Here we go. 2 minus 1 is 1. 3 minus 2 is 1. So how many square centimeters of red paper will be visible? It's 11 square centimeters. All right, you guys did a really nice job. So go ahead and take your paper and turn it in. Nice job today.